everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about discriminants of quadratic equations. Like many things in math, there are big names for things that are actually kind of simple. You will find this a lot. Yes, it can be annoying. I'm sorry. I didn't make the names. Somebody long ago made all these names, or somebody's long ago made all these names, and we just have to live with them. Sad but true. Right, quadratic equations. Quadratic equations are things that look like this. Or maybe just like that. Or maybe like that. Have to have an x squared. All of these quadratic equations can be represented by this, ax squared plus bx plus c, where a, b, and c are constants. A constant, plural, I have such a hard time with that word, are constants. That is, they are numbers. They are not variables, they are numbers. They sit there, they're numbers. So all of these, even the one that was like x squared minus 9, you could write it as x squared plus 0x minus 9. Everybody with me? You may have seen this used in conjunction with the quadratic formula. If you're not familiar with the quadratic formula, I do have a video down below. Quadratic formula looks like this. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And your a's, b's, and c's are referring to these three numbers from the quadratic formula, from the quadratic equation, that you're trying to solve. The discriminant is just this part, b squared minus 4ac. You don't include the square root over it. It is literally just that. So if they tell you, find the discriminant of this equation, all they're saying is use this little formula, b squared minus 4ac, and plug the numbers in and tell us what it equals. And you go, okay, but why? Why, teacher person, am I being asked to do this? What is the point? There is a point, I promise. And here it is. When we're talking about quadratic equations, a lot of times they'll say, what are the solutions? What are the zeros of this? And what they mean when they're saying, what are the zeros, is if I have a quadratic, it's like a little parabola, looks something like that. They're wanting to know where it crosses the x-axis. Well, what if this thing doesn't cross the x-axis? What if it goes up here? Does it have any solutions? No, it doesn't. It has no solutions. It doesn't cross it anywhere. There's also some that might have one solution. That is, they just go boop and they just touch it. Without going through the more extensive quadratic formula, you can tell how many solutions an equation has by using the discriminant. And the reason this works is because of where it sits in the quadratic formula. Because let's look at this. If I have x equals negative b plus or minus square root of b squared minus 4ac all over 2a. It's like you have to take a deep breath before you say all that. What would happen if I got something like, say, I don't know, let's say I ended up with it's 5 plus or minus the square root of 16. Okay, square root of 16 is going to be a positive number, 4 plus or minus 4. So I'm going to have 5 plus 4 over 2 and 5 minus 4 over 2 is my answer. 2 answers, right? If I have any positive number under here, even one that doesn't have a perfect square root, I'm going to have 2 answers because it's going to be 5 plus this positive answer, whatever is out here. It doesn't have to be 5. Going to be adding a positive answer and then subtracting a positive answer. So I'll have 2 solutions. That is to say, when b squared minus 4ac is positive, there are 2 solutions. Right? What might make it have 0 solutions? Well, what if the b squared minus 4ac underneath this radical gave me 0? Well, then I'd have 5 plus 0 in this example over 2 and 5 minus 0 over 2. That's the same thing. So when b squared minus 4ac is equal to 0, there is only 1 solution. And last but not least, what if this turned out to be like something like, say, -10? Now, we're not talking about imaginary answers in this one. We're only talking about real solutions. I should say that all of these are real solutions. Only. So if there's a negative under the square root, it doesn't matter if I have 5 plus and then 5 minus. Those aren't real solutions. So I bet you never see where this is going. If b squared minus 4ac is less than 0, there are no real solutions. Okay, now I didn't just draw this graph in the middle here just to divide my screen nicely into 4 lovely different quadrants. Oh, no. We're actually going to draw some parabolas and do some little discriminants just to show you that this does in fact work. Aren't you excited? Oh, I know it. I can feel the excitement coming through my computer screen, just like, yes, I would love to draw parabolas and find discriminants. You read my mind. This will make my day. Glad I can help. All right, here's our first one. X squared plus 10x plus 21. Okay, all right, x squared plus 10x plus 21. I'm going to use my little discriminant. I'm going to say b squared minus 4ac. My b is 10, so 10 squared minus 4 times, my a is 1. That's an invisible 1, but it is there. 4 times 1 times 21. So 100 minus 84, 16. Hey, that's positive. So it should have 2 solutions. Well, if you put this into a graphing, I squeaked. If you put this into a graphing calculator, you are going to get, it's like 1, 2, 3, 4, 5, 1, 2, 3, 4. You are going to get a parabola that has, if I'm not mistaken, it has a vertex at -5, -4. And it's going to cross, I didn't draw this long enough. Okay, at -3 and -7. So something, wow, that's awful. I have never said that drawing parabolas was my forte. Hopefully you get the idea from that awful parabola. But look, I was right. It has 2 solutions. Hey, I like, this is painful. All right, that's a little better, right? Nope. I'm giving up. I'm giving up on that one. Moving on. We'll pretend that awful parabola didn't happen. Okay, so there, x squared plus 10x plus 21. That gives me 2 solutions with my discriminant, and it was right, 2 solutions. Next one. I'm actually going to write this in blue so that it matches the parabola. I'm color coordinated and organized. All right, x squared plus 8x plus 16. So again, this was a positive discriminant. All right, so this one, b squared minus 4ac. My b is 8, so 8 squared minus 4 times my a is 1 times c. My c is 16. 8 squared is 64. 4 times 1 times 16. Also 64. It equals 0. So that's telling me there should be, this is equaling 0, that there should be one solution. The discriminant was 0, one solution. All right, well, let's go over here and we tell our graphing calculator to graph it. And sure enough, it only touches the x-axis at one point, and that's at -4. Ugh, not my forte. And then it goes up. All right, and last but certainly not least. Why do we always say that? Certainly not least. Maybe it is least. Maybe this parabola is like the least parabola to ever have parabolaed. And the last one here is 2x squared plus 4x plus 4. Same thing, b squared minus 4 times a times c. We want to know how many solutions it has. B squared, my b is 4. 4 squared minus 4 times, my a is 2. My c is 4. 4 squared is 16. 4 times 2 times 8 is 64. Ooh, 16 minus 64 is, oh, I'm blanking. Is that 48? Negative 48? Let me double check that. Yes. Yes, negative 48. My mental math is not at its peak this morning. It's early. All right, so negative 48. I'm getting a negative number for my discriminant, which means I should have no solutions. I type this into my little handy-dandy graphing calculator, and sure enough, I get a parabola with a vertex here at -1, 2, and it goes up. I'm so bad at this. There we go. Goes up something. Don't judge me for my parabola drawing skills or lack thereof. So there you go. We can see this, that it is true. So again, if your discriminant is positive, you will have two solutions. If it is 0, you will have one solution. If it is negative, you will have no solutions. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.